Good morning everyone. So welcome to my YouTube channel Math Sapram. So today we are going to see third lecture on Riemann integration. So let us start today's session now. So I recall a result which I have proved in last lecture. Let closed interval a b to r be a function of bounded variation and p be a partition of AB. We have we have m times b minus a less than equal to LPF, that is less than UPF, and that is less than capital M times b minus a. Okay. Okay. Now, now since m b minus a, from here what is clear? It means UPF is greater than this for any partition P of AB. So this implies, because this is a fixed quantity, fixed. So this implies m times b minus a is less than so now this implies UPF P is a partition of closed interval AB. This set is subset of R is bounded below in R by small b minus a. Okay. So by order completeness property, if a subset of R that is bounded below in R has always infimum. Okay. So by order completeness property, of real numbers, we have UPF supremum, UPF P is a partition of AB exists in R. So supremum exists in R. Okay. We call A to B fx dx is equal to supremum, this supremum. UPF P is a partition of A. Because this supremum exists in R, so I am calling this A to B dash line. There is a straight line at above of the integral. So this is called upper Riemann integral or just upper integral. You can say upper integral. Similarly, we have LPF is less than capital M B minus A for any partition P of AB. So this implies LPF P is a partition of AB is bounded above in R by capital M B minus A. By order completeness property of real numbers, if a subset in R that is bounded above, that has always supremum. Okay. Sorry, here I made a mistake actually. By order completeness property of real numbers, infimum will exist. Infimum will exist. Okay. So I am calling this infimum because by order completeness property of real numbers, if a set is bounded below, okay, that always has an infimum. So this infimum will exist. I am calling this infimum as a upper integral. Okay, infimum. Now LPF is bounded by capital M B minus A. Okay, by order completeness property of real numbers, supremum of LPF P is a partition of AB exists in R. Okay. We call A to B fx dx this supremum LPF. P is a partition of AB. We call it lower Riemann integral. Lower Riemann integral or just lower integral. Okay. So we prove a result theorem. Let F close interval AB to R be a function of bounded function be a bounded function. Then M times B minus A is less than equal to lower integral dx, that is less than upper integral fx dx, that is less than capital B minus A. Okay. So let's see its proof. By theorem of Riemann integration, lecture 2, we have MB minus A less than A L P1F U P2F capital M B minus A for any partitions P1 and P2. Okay. So let's say equation number 1. Now P1 and P2 partitions of closed interval AB. Keep P2 fixed and taking supremum in 1 over the partitions P1 of closed interval AB, we get, okay, we keep P2 is fixed and we are taking supremum of partition P1 of closed interval AB. What we will get? We will get M times, because this is a fixed quantity. So by taking supremum, what you will get? You will get A to B fx dx is less than equal to UP to F M B minus A. Okay. Now, taking infimum into over the partition P2 of closed interval AB, we get, what we get? Now, this lower integral is fixed and this is also fixed. So taking infimum will be in between these two quantities. So this is less than B minus A is less than A to B fx dx is A to B upper integral dx M B minus A. So this is proof. So we got the result. Okay. Now how to calculate upper integral and lower Riemann integral? So example, let fx, I am taking 0 if x is rational in closed interval 0, 1 and it is 1 if x is irrational in closed interval 0. Okay. So this function is Dirichlet function. This function is Dirichlet function. Okay. And f from closed interval 0 to 1, 0, 1 to R is bounded function. Okay. Because its value, minimum value is 0 and maximum value is 1. Okay. In lecture number 1, in Riemann integration, lecture 1, we calculated that UPF is nothing but 1 and LPF is nothing but 0 for any partition P of closed interval AB. Okay. Now so this implies, what is upper integral? This is equal to infimum of UPF. C is a partition of AB sorry, here closed interval is 0, 1. For any partition of 0, 1. So, but this is 1. Every time you take any partition, this is 1. P is a partition of closed interval 0, 1. So, you are taking infimum where each term is 1. Each value is 1. So, what is the infimum? Infimum is 1. Okay, because infimum of a constant function, okay, or constant values is equal to that constant. So, infimum is 1. So, this implies dx is 1. It means upper Riemann integral is this. And let's calculate lower Riemann integral. What is that? A to B fx dx is equal to supremum of LPF. P is a partition of closed interval 0, 1. Now this is supremum. Each LPF is 0. You take any partition, LPF is a 0. Now tell me what is this? Because supremum you are taking, each value is 0. Okay, so this is 0. So this implies A to B fx dx, that is equal to 0. Okay, so you have calculated lower Riemann integral. So finally we have A to B upper Riemann integral is equal to 1 and A to B fx dx is equal to 0. Okay, here A to B fx dx is strictly less than A to B fx dx. Okay. It means what? They are not equal. It means I am writing in bracket. It means A to B fx dx is not equal to A to B fx dx. Okay. We know that lower integral less than equal to upper integral, but here it is not equal. Okay. And it means they are strictly less than. Lower integral is strictly less than upper integral. Okay. So now move to next example. Example 2. Let fx is equal to c for all x belongs to closed interval AB. Okay. Then f closed interval AB to R is a constant function. So this implies f is bounded because constant function, it is taking value on 1. So it is bounded by this C. So f is bounded function. Bounded on closed interval 0. So in lecture 1 of Riemann integration. In lecture 1 in Riemann integration, lecture 1, we find that UPF is UPF is C times B minus A. Okay, and LPF is also C B minus A for any partition P of closed interval AB. Okay, so now what is upper integral, upper Riemann integral? This is infimum of UPF. P is a partition of AB. Okay, now this is infimum. What is the value of UPF? This is B minus A times P is a partition of closed interval A. Now you see that this value is fixed. You take any partition, this value is fixed. So infimum will remain this, okay? Because this is a constant value for any partition. So B minus A. So this implies upper integral is equal to C B minus C. And lower integral is supremum LPF. P is a partition of AB. So what is this? LPF is also C B minus A. So P is a partition of AB. Now this is fixed. You take any partition, this is going to be fixed. So what is this? This is nothing but C times B minus A. Okay. So this implies A to B this implies A to so this is lower integral A to B fx dx is equal to C B minus. Okay. Finally, A to B f dx is equal to C B minus A. Okay. And lower integral is also same. That is also C B minus A. So here lower integral is equal to upper integral, because both are C B minus A. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. So thank you very much for today's lecture. We will see you in next lecture. Thank you very much. Like, share, comment and subscribe my YouTube channel. Thank you very much.